Hello, this is Jeff Badge of the Grinding Dock, and we are going to talk about thermal conductivity in abrasive grits, or thermal conductivity specifically in aluminum oxide versus CBN. And this is one of the unsung attributes, one of the underappreciated benefits of CBN grits. So when I give my courses, I use this for aluminum oxide and I use this for CBN. This is not aluminum oxide, this is not boron nitride. This is a rock and this is another rock, but this is what I use, okay? And CBN is harder. We all know that. CBN is a harder grit than aluminum oxide. But one of the benefits of CBN that people don't talk about is CBN has a higher thermal conductivity than aluminum oxide. So if we grind with aluminum oxide and we do a lot of rubbing, which most of the energy in grinding goes into rubbing anyway, we're rubbing. We're generating heat. And 90% of that heat goes into the workpiece. 90% of the heat is going to the workpiece, and 10% is going to the grit. Okay, that's the rubbing energy. If we have a boron nitride has a high thermal conductivity. So as we rub, which we do, maybe only 40% of the heat goes to the workpiece, and 60% of the heat goes to the grit. 60% is more than 10%. So what we're doing is we're sucking heat out, it goes into the grit, and then the coolant splashes around and cools down the grit. And so we are having heat go into the grit and not in the workpiece. And that's fabulous. That's what we want. Okay, we want heat going into the CBN grit. Now that's the theory. Is it true in practice? Let's take a look at some work done by the Fab Four Liverpudlian grinders, Vadam, Chen, Mike, and Brian at Liverpool John Moores University. And here is the grinding power they measured versus the depth of cut with identical conditions. Same cooling, same wheel speed, probably, I think so. Same wheel diameter, same feed rates, same material removal rates, same everything. But they did it with a CBN wheel and did it with an aluminum oxide wheel. And look at that. The CBN wheel was generating more heat. Now, it's generating more heat. There's a lot of reasons behind this. It could be due to the smaller grit size. It could be due to the choice of wheel speed, something else. It's not necessarily bad. It's just the way it is. But the CBN is generating more heat. But you might think, oh, that's bad, because for a given arc length and everything else, if the CBN is generating more heat, then that CBN wheel is going to give us higher temperatures. But then they measured the workpiece temperature. And look at this. The workpiece temperature in the CBN was actually a little bit lower than the workpiece temperature in the aluminum oxide. And this is our friend Brian Rowe, one of the grinding greats, one of the world grinding greats. So what we see is, hey, we're generating more heat with the CBN, but we're getting lower temperatures, and we're getting lower temperatures because CBN has a high thermal conductivity, and that's a nice thing to have, a high thermal conductivity. And there's another graph, which I'm not going to show, which has the CBN and the aluminum oxide generating the same amount of heat, and they generate the same amount of heat, but the CBN gives us a lot lower temperature. And the reason is because CBN, when it rubs against the workpiece, sucks up a lot of heat. And if we're doing that and it's sucking up a lot of heat, that's heat not going into the workpiece. So that's not to say you should run out and use CBN. It's not to say aluminum oxide is bad, but it is one of the benefits of boron nitride abrasive over aluminum oxide. Not just the hardness, but also its heat sucking ability and reduced temperatures in the workpiece. And then, as we know, high temperatures in the workpiece cause residual tensile stresses, over-tempering, thermal softening, rehardening burn white layer, lower fatigue lives, maybe cracking, bad things. Okay? This is Jeff Badge of the Grinding Dock, talking about grinding. This is the stuff I teach in my grinding courses, and this is the stuff I teach when I come to companies and I help them grind better.